Dear participants, good day. Can you hear me? So welcome to the IEEE Forest International Conference. So I would like to just inform that the presentation time is limited for 7 minutes, and then you will have 3 minutes for a Q&A. So good luck. And we need to start in the order of the presentation. So the first presentation should be ID 123. Igor Matveyas, are you here?
Yes, can you hear me?
Yes. So can you share your screen? And also,
of course.
duration of IEEE conference, you need to turn on your camera during the presentation.
Sure. 1 second, please. Now it should work, I guess. Do you see my web camera and my screen?
Yes, we can see. You can start.
Yep, great. So good afternoon. My name is Yegor, and today I will be showing you our presentation about our research work. And our topic is research and development of sign language recognition system using neural network algorithm. First of all, when we talk about any research work, we should say about the aim of the research. And in our case, the main idea of this work was to create an optimized and integratable real-time system, which will allow us to recognize and translate American Sign Language, or maybe any other language, any other sign language. And we also need some motivation when developing such systems. And in our case, we had 3 main points. The first one was that there are a lot of different sign languages in the world, for about 200 different sign languages, which is very huge. And next point was that the community of deaf people is also huge. There are more than 70 million people worldwide who has some problems with hearing. And yes, the last reason for or motivation was that computer vision sphere is popular now, and every year its impact to the humans' lives increases. And yes, about the research process itself, the first step was to solve the problem with data representation and processing. And for this purpose, we decided to use MediaPipe library, which provides us some tools to get key points of different parts of human's body. For example, from this MediaPipe library, we used hand model containing 21 3D key points. We also used facial landmarks represented by 268 3D key points, and we also used human pose representation. And in total, what we did, we change the structure. So we created our own structure represented by a single-dimensional array, which contains 1662 numeric values. And yep, it means that each frame of sign contains such number of numeric values. And actually, each sign is represented by 24 frames. And in total, when we were preparing our training dataset, we collected 150 variations of each sign. Then there was a task to decide which word, with which words do we want to work. And we collected 13 different words, and we also made a dictionary represented, which represents the number of phrases or sentences which can be recognized by and translated by the system. And as you can see in these two tables, the number of words is 13. So we have 13 different words, and our system can create from these words some phrases and sentences which are represented in the second table. And talking about model, first of all, we created compact version, which consists of 5 different layers, including the input layer and output layer. And then we made some enhancements to it and improved its performance. And the final version of model is shown on the left side, and it contains 8 different layers, including input and output. And as you can see, for input layer, it contains a sequence of values. Yes, and the sequence represented by 24 frames, and each of these frames represented by 1662 numeric values, what I talked about before. So our experiment was represented by training process.
Yeah, I have a question.
Yep.
So the question answer session will be after the presentation, guys. Okay. So, and Yegor, also you have a minute left.
Can I continue?
Yes, yes.
Okay, cool. Yeah, so what about experiment? We were we made our training process for both models and compared them by the different amount of epochs of training. And as you can see, there were two main types of amount of epochs, 25 and 75. And there's also some results of loss in accuracy we got while training our models.
So, Yegor, thanks for your presentation. It's already time. So, do you have questions?
Yeah, I have question. Can your model be used for other sign languages?
Yes, of course, because this model actually doesn't. It is independent from the sign language itself. It just works with some data, and when if we want to apply this model to another sign language, we only need to create and collect data set for that language. And yep, actually model works with any sign languages.
Okay, thank you.
So, other questions from the audience? So, I think there is no question. So, thanks, Yegor, for your presentation.
Yep, thank you.
Yeah, we can continue with the next speaker then. ID 129, Timirhan Tarbek Asyar Mukasheva. Could you please share also your
Yes, I'm here.
presentation? And also please turn on your camera. Thank you. So you have 7 minutes for presentation.
Okay. Can you see my stream?
Yes, we can see.
Hello, my name is Timirhan, and my research is research and development of two-factor authentication methods using neural networks. And in my research, I compare many types of authentication. It is first of all examples. We have solved it in the three types of authentication. First of all, it is the ownership. Second one is acknowledge, and the biometrics. Ownership is like a case and code. Acknowledge it is the simplest name and password, and the biometrics. Biometrics it is no what we have. It's for example handwrite, face, fingerprint, and all and etc. How I choose the first one. It is a face recognition. This there are how face recognition works. It is a input frames, processing, face recognition, feature extraction, and the feature matching is neural networks, and is a compare for face database, and user identification and authentication. There I show how in the face recognition works in the mass. Then second factor I take time based at one time. It is and the how it works. First of all, it's a shared secret code, a time based one-time password, and this is the secret code. The mass of time based one-time password, how it works, and there's this codes, and the authentication process.
Oh,
Sorry, I had some lags. Okay, first of all,
Alright.
our program start. What? First of all, it is a start and the face scanning. If face scanning was successful, it will be yes, and the token verification via Telegram. Or no, repeat the process of again face scanning process. And after the token verification via Telegram, and we put the Telegram verification is if successful, it will be end. Authentication process when the attempt to log in, the user will have to go through facial recognition, after which a OTP will be sent to the via Telegram bot. Thus, using two-factor authentication via Telegram bot with OTP and facial recognition provides a higher level of security than simple password authentication. This is due to to the fact that to gain access, one must not only know the password but also have access to the mobile device and undergo facial scanning. And the performance test and results. First of all, we must to register register the user. There are two types, two two things to users. It is first of all ID number and the name. First of all, we must sample or register. First of all, it is a register type, the picture, and the second one that we must train the number of frames, and after training images, we must check it. After checking the face scanning, the how much frames and how much percent satisfaction to the registered image. And after it, if it is successful, we must send a Telegram one-time password. Every user have who have Telegram, he has his owner Telegram ID. For example, there are my 404 to 22 or 634, and we must send verification code. After this, we take Telegram code, which active in 60 seconds. And after this, we put in, and the verification is successful. In conclusion, creating two-factor authentication using facial recognition and TOTP code generation via Telegram bot is an effective way to protect that data and secure access to resource and reserves.
Sorry, guys, we can see only for your second page.
Second?
Yeah, only second page. So I think you were now showing the different pages. Yes.
Sorry, I don't listen you very well.
I'm saying that we can see only your second page.
Which second page?
We can see only your second page of presentation. I mean, you're sharing only your second page, this one, authentication example.
You see only this?
Yes. Yeah, yeah. And looks like you continued with another, right?
No.
Okay. You described it just second. Okay.
Also, you have only 1 minute left.
Okay, I just can show like this. The how face recognition works. Here's a mask. The time-based one-time password. How it works. Here's a mask and the authentication process. Start face recognition. If successful or no. Then this if no, it's a repeat face scanning. If yes, Telegram verification code, and if it's successful, he will end the authentication process. Comparing this, how program works, the user's ID, username. First of all, we must save. Then we train it this image and testing. After testing successful, we also register to user his Telegram ID, and after sending verification code, we take on our Telegram one-time password, which active in 60 seconds, and put this there. And if it's correct and the time is in the 60 seconds, to put it here, and verification successful. So that's all. Thanks for attention.
Well, thank you. Thanks for your presentation. So, audience, do you have any questions?
Yeah, I have a question. You told that you're using two factors of security. So my question is, why you're using these two factors, and what about another factors? Is it possible to use it?
Yes, I take that two factors because I aim it to a more cheaper method, because everybody have, for example, mobile phone with using internet, and everybody in the work station have camera. This methods will be cheaper to realize, and it's simply to use, because in this method we don't must to know passwords, usernames. We just only have to camera, our face, and using telephone. mobile telephone.
Okay, thank you.
Anybody hear me?
Yeah, we hear you.
Hello, sorry for any inconveniences. So can you hear us?
Yes.
Yeah, so, and then maybe we will continue with our questions to Timurkhan.
Yes, I'm here.
Okay, thank you for your presentation. Do you have other questions, right? Participants? So Timurkhan, thanks. So it means that we can continue with the third presenter, ID 141, Artur Tosatayev.
Yes, it's me. I believe you hear me.
Yeah, can we share this screen?
Okay, give me a few seconds. I've lost. Okay, I hear. Do you see my screen?
Yeah, we can see you, but your presentation.
I'm sharing my screen right now. Okay, maybe.
Yeah, okay.
Do you see my
Again,
screen
you
now?
have seven. Yes.
Okay, perfect. So yeah, hello everyone. Good afternoon. So my name is Artur Dostaev. I'm a PhD student of International IT University in Almaty. So my topic is deep learning-based framework for option price forecasting. And today I want to present you with my investigation. So the basic idea to investigate different deep learning methods and models for financial markets, especially like option prices, time series data. So in particular, convolutional STM model to capture both like spatial and temporal dependencies within financial option prices time series data. Yeah, what's the difference? Convolutional LSTM has benefits of both convolutional and recurrent neural networks compared with LSTM. So LSTM, yeah, for sure handles information like single stream, text or time series data for sure, but convolutional LSTM can handle information with spatial details like images or complex financial time series data. Yeah, so it's a benefit, and overall it could be great, and overall I've got really good results because of the nature of option prices. Yeah, yeah, in short about input data, and overall option prices are quite complex and not highly available compared with, for example, stock market data or like crypto market data, because it's like second, how it's called? Oh, second. Okay, options are having underline behind them, and second order market data, so they are not highly available. So I have around 500K of data points, so 2+ years of data and more than 100 plus pairs of strikes explorations. And this is exactly why convolutional STM can work good, because for each timestamp, we have a pair of strike and expiration. So this spatial dimension, which is more like image data. So here's a learning curve. As a metric, I've used root mean square error. Here you can see it. Here predictions versus actual, which is good. Okay, wait. Which looks quite good, very similar, and performance metrics are also quite good. I had but I had 200 epochs, and root mean square error of this model was 0.71, and compare with Black-Scholes-Merton model, like it's a standard in financial market, so mostly like companies are using BSM just for simplicity, because overall it gives pretty good result. And yeah, root mean square like 9 times more, 8 times more, and accuracy rate is 92%. So yeah, final words and challenges for this model. Overall, data complexity, options are very sensitive to various factors. First of all, it's definitely underlying as a price, for sure volatility, interest rates, time to expiration, so a lot of different factors affect it. And yeah, convolutional STM may struggle, but overall, this model provides quite good results. Yeah, definitely this model requires a lot of data. And yeah, for options, it's definitely a bit hard to gather, but yeah, sometimes it's possible. And interpretability is also an interesting question in all like deep learning models. So it's sometimes too hard to explain why this model give such result. And yeah, definitely you should use with caution results of this model. So benefits. So since I've mentioned that option prices structure is the same, is that for each timestamp you have several strikes, several what's called time to expirations, and also like they are heavily influenced by sensitivity factors like delta, gamma, theta, vega, and few other like convolutional STM can capture these spatial dependencies, and also LSTM itself can capture daily, weekly, monthly patterns historical of history of time series. So yeah, I think that's it. I spent maybe 6 minutes. I have one more for your questions, maybe.
Yeah, you can continue. You have 1 minute left.
Actually, I tried to deliver as much as possible, so that's it. So overall, the results is that convolutional STM models are pretty good for options prices. LSTM itself are pretty good for time series, but convolutional could be pretty good for option prices. And I will like try a few more iterations with like mix of different models in the future. So what's the main idea to like prepare automated trading system to capture like arbitrage opportunities? So yeah, that's an idea.
Thanks.
Okay.
Other participants has a question, because I think in our chat we have a question related to stock price or something like that.
It's actually not a stock price, it's actually option price. Options are second order financial instrument, which are dependent a lot of underlying price, for example, on stock. So you can have option prices on Apple stock, for example, and using options, you can, it's like insurance for you to eliminate risk. So that's the main idea. Yeah, it's options on weeks. It's weeks options. Yeah, I've got your question. Thank you, Aisha.
Yeah, thanks, Alshan, for your questions. So I think we can continue with speaker. Do you have any questions? Artur, do you want to say?
Sorry, my questions?
Yeah, do you want to continue to say something?
No. I've got everything, so I've already presented.
Okay, thank you very much.
Thank you.
Yes, so now we need to continue with our offline presenter, Aron Karatayev.
অডিয়েন্স কোশ্চেন করতেছে।
So Irina Mukambayeva, ID 177. Are you here? ID 177.
Yes, I'm here. Okay, is my sound?
Yeah. Can you start, please? So you have 7 minutes, okay?
Okay, thanks. In terms of the state investment budget on the Kyrgyz agricultural sector through data analysis, we would like, that was our plan, to select and assess factors influencing the gross output of the X sector of Kyrgyzstan, concerning, of course, the specifics of its agricultural producers. The analytic methodology we used made it possible to identify the main statistical connections of a selected factor with the resulting indicator. We, of course, at the beginning we had 10 factors, then we reduced the number of factors from 10 to 6, and the remaining variables are presented in the following order: average monthly per capita income, mineral fertilizers, prepared.
Здесь будешь? Здесь? Как? Ну, в смысле, в Астане?
Investment. I switch on my.
Could you please turn on your camera also? We cannot see you.
Oh, is it okay now? I have to explain that the number of producers in the agricultural sector, the population of Kyrgyzstan, the zone areas under agricultural crops, and total number of livestock and poultry were excluded during our research by us due to their multicollinearity and usualness. Actually, everybody, when analyze agricultural sector production, take number of producers and so on. This is table of pair correlation metrics, and after some proceedings, you may see the 3 selected factors: average monthly per capita income, investment in fixed capital, and state investment program budget. As can be seen from the result obtained, the category average per capita income has the greatest positive return. An increase in it by 1% will increase the GO of the sector by 0.82%. And actually, it should be noted that an increase in the average per capita income of the population, first of all, increases the demand for food. So the growth of this indicator has a positive effect on increasing the volume of gross output of the sector. Не надо Enter нажимать у меня. Sorry. So 1% increase in fixed investment reduces sector GO by 0.32%. The very ambiguous result of the negative impact of investments in fixed capital of the sector is associated with the specific of its producer, when the bulk of production is produced mainly by small-scale peasant farms and subsidiary plots of the population, and large and medium-sized producers represented by the state and collective farms provide only 4.4%. And we need to explain additionally peasant farms and private household plots do not generate and submit reports to statistical authorities. Therefore, data on investment in fixed capital in the sector reflects only indicators of state and collective farms. Actually, we paid a lot of attention to check the quality of the model, and now you can see the figure, reconciliation of actual and theoretical results. The analysis methodology we used made it possible to identify the main statistical connections of selected factors with the resulting indicators. Resulting indicators is GO, as you understood already, and created the basis for forecasting their changes and developing appropriate measures to increase the volume of gross output of the country's agricultural sector. Thank you for your attention.
Okay, thank you very much for your interesting presentation. Do you have any questions, audience, participants? Okay, can I ask you, in your previous presentation page, you showed us the results. And here I want to ask, how did you obtain the theoretical part?
Sorry, my previous presentation.
No, 11th page. There you have the result.
What? There is the result. Yeah, this is situation. Some people thought that the, for example, elasticity cannot be negative, we cannot get minus elasticity, but there are a lot of experts that it's possible to have minus elasticity index. And of course, we had to explain the situation. Actually, the main producers are not represented in official statistics, I would say in any statistics in Kyrgyzstan. And so that's why we got negative or minus elasticity.
Okay, thanks a lot.
The rest, they have good behavior. They increase the GO with their own increase.
Okay, thank you. So other questions?
Okay, thank you very much. We finish.
Yeah. So the next center will be offline.
Next presentation, ID 144. Okay.
Next slide. So the research relevance comes on the critical software testing issues. Many of you know that the software testing is a pretty time-consuming and resource insufficient process, whereas the quality standards stay still high, and we have to support them. So like this. So given these needs, our main of our research is to build a test case prioritization system in order to solve these problems by implementing a fuzzy logic approach. So talking about the significance and novelty, I hope the significance is clear based on the previous slides, and let me focus your attention on the novelty. As you may see, we attracted the key experts. It is not only for the evaluating the results, but also for building and constructing the fuzzy rules and fuzzy sets. Another novelty part in our research is uniting the fuzzy and increased parameters in order to build a convenient escape prioritization system. Our methodology based on the consists from the two parts. The first one is to build a escape prioritization system, and the second is the performance evaluation of this. But before we start building some systems, we have to data sets. And actually, during our research, we used more than 150 test cases from 4 different real production products. And on the screen, you may see the main table structure and automated test cases from e-commerce platform. Talking about the processing, and on the screen, I hope you can see pretty clearly the whole algorithm of our research. So firstly, you may see how test cases go to the fuzzy evaluation model, and as a result of outputs, priority, we adding the non-fuzzy and increased parameters, and the final result, we get the shortest list of test cases. So talking about the input parameters, so on the screen you may see the 3 fuzzy sets, 2 of them as input, such as execution time and the failure rate. Execution time is about how many time you spend on the running each case, this test case, and the failure rate, how often it fails, obviously, and the outputting set is a priority. Moreover, in the table in the right corner, you may see the increased parameters, such as the prerequisite test case and recently uploaded flag. So what does it mean, a prerequisite? It's obvious thing, because let me explain on the example. You cannot run logout test case before you log in, isn't it? So I know recently updated is just a flag. Our functionality and the test was updated in the latest release, maybe. So to make the whole system work, we need a correct and true fuzzy rules. In our research, as I mentioned before, we attracted QA engineers and other experts. During the session of surveys and interviews, we built this 20 fuzzy rules for our system. Thank you. Let me present you our computational results. On the screen, you may see the result of our fuzzy evaluation model. And that's something test case with a 20 seconds execution time and 65% of failure rate, giving us the result of almost 78 points of priority. On the screen, in the left side, you can see the bar chart. It's resulting of our mentioned before test case of 20 cases sorted in order to lower to high priority. And on the right side on the table, you may see the result of our algorithm after implementing and adding the crisp parameters such as prerequisite test case and the recent level flags. So please next. So to evaluate our results, we decided to compare with sorting provided by senior QA specialists. And as you may see, the resultant number of our test cases of our proposed algorithm is 26. But we remember it was started only from 20 test cases in general. But why, you may ask? It's because the prerequisite parameters. Because during the testing, you have to cover different test cases and scenarios, and you have to rerun some tests. And as you can see, our metrics is execution amount of tests, spend time, and failures found. So the unsorted column is how the system worked before the implementation of any sorting. And the QA specialist, as mentioned before by specialist, and our is in our proposed algorithm actually gives us a pretty similar results to the experts with specialists, which actually give us the convenient system that may shrink the force specialists during the job and attract the less expertise for more specialists in our project to not sacrificing the quality. So thank you for your attention, guys. I'm happy to answer questions.
Thanks a lot. So the audience, do you have any questions for our presenter? So I have actually one question. So in this presentation, you said that in general, I'm not a fuzzy logic expert. Okay, so and you said that sometimes it happens that you are rerunning this.
Yeah.
So is this rerunning like actually affect to your results?
No. Rerunning means when you have to cover different test scenarios. For instance, you have the first test scenario, you have to add some, for instance, like e-commerce project, you have to buy one product and you have to remove it from the cart. And so the test case of adding product to the cart will be run twice for this scenario. Do you understand? That's why we have a run. That's why it's 26 test cases from the list of 20 test cases.
Yeah. And one more question here. Also, I'm not expert, but for me it's very interesting. So I think from these three versions, one of the more effective is unsorted. Am I right? Because the data can be different.
No, actually, unsorted means it's not another type of data. It's all the same data they use, and it's approach how automated tests performed before we started any testing, optimizing and sorting activities. So, for instance, there is a QA automation engineer who have to cover the release by tests, and he has a 20 test case, and he have to cover all the scenarios. So he runs 32 test cases in order to cover just all. He does not matter about the spend time and other parameters, just like as it was written, as it was on the project before. It is not actually random.
Okay. Okay. Thank you.
Thanks.
Thank you much. Goodbye.
Goodbye.
So now we need to continue with ID 179. Serhiy Dolhopolov, are you here?
Yeah.
Yeah, can you please show your presentation?
Okay, just a sec.
Also, could you please turn on your camera during the presentation? Okay. Yeah, so also you have 7 minutes, okay?
So I hope you can see my presentation. So let's get started. Greetings to all present. I'm Serhiy Khopolov, an assistant lecturer at the Kyiv National University of Construction and Architecture. And I would also like to introduce the co-authors of the research, namely Tatiana Goncharenko, Olena Fedushenko, Volodymyr Kharlenko, Vladislav Hots, and Volodymyr Holenkov. Ladies and gentlemen, we're glad to present you a report on neural network threat detection systems for data branch protection. We're at a pivotal moment in our digital age, and every bit of data, from trivial to sensitive, shapes the digital landscapes connecting us all. And this landscape, rich with opportunities, also harbors escalating risks as technology evolves. So information today fuels everything, government decisions, corporate strategies, and our personal lives. And however, more data means more potential breaches, which traditional cybersecurity can't effectively guard against anymore. And why is this important? Reports like IBM Security 2023 year findings highlighting resign data breach cost affecting both finance and trust, and this urgency drives our exploration into neural networks using machine learning to create systems as dynamic as threats safe phase. And our ambitious yet crucial goal is to revolutionize cybersecurity by harnessing neural networks capabilities, where developing systems that not only detect threats as they happen, but anticipate them before they occur. And for this study, we have leveraged the KIDD99 datasets, a benchmark in network security analysis, and this dataset serves as a foundational pillar for testing the accuracy and robustness of our threat detection models. This figure on the slide illustrates the balanced ratio of normal to abnormal data, and we aim for crucial for training robust neural network models. The architecture of our neural network shown in this figure is designed to handle varied and complex data inputs. It's a fully connected fit-for-all neural network, and with layers tuned to recognize and react to cyber threats, from simple DOS attacks to sophisticated remote to local and user to root intrusions. And this architecture is ideal for classification tasks, categorizing input data into various classes based on learned patterns from training data. Our approach is built on the robust NSL KDD dataset, which mirrors real-world challenges faced by intrusion detection system IDS, and this dataset captures a wide range of internet traffic scenarios, including both normal operations and malicious intrusions. The NSL KDD dataset has 43 attributes, 41 detailed traffic characteristics such as packet size and protocol types, while the remaining 2 are labeling attributes, and these labels indicate whether the traffic is normal or an attack, and assess the sensitive, severity, and potential damage, guiding our neural network to prioritize threats effectively. And this table shows the distribution of attack types across different subsets of the datasets, and this detailed breakdown helps fine-tune our model sensitivity and specificity, which is crucial for developing and balanced and accurate IDS. This figures visualize the protocol types, TCP, UDP, and ICMP, with TCP dominating due to its reliability in internet packets delivery. This highlights the importance of focusing on TCP traffic for effective anomaly detection. The next figure compares normal and abnormal conditions within each protocol types. providing insights into expected patterns versus potential threats, and this help our system learn to distinguish between normal behavior and anomalies. And the last figure analyzes protocol flags, the confusion matrix, which further categorize network behaviors and responses, and each flag indicates different network session states, such as establishment, transfer, or termination. The next figure displays the confusion matrix for our deep neural network. This matrix visually represents the model's classification accuracy divided into 4 quadrants, and Table 3 expands our analysis to include various models such as KNN, logistic regression, decision tree, and gradient boosting models like XGBoost and light gradient boosting. The diversity in these results highlighting each model's strengths and weakness in different scenarios. The next table presents the accuracy of each models during training and on the testing sets. This dual perspective helps us assess not only how well each model learns from the training data, but also how effectively it generalized to new unseen data. To summarize, we evaluated various models with top-performing assembly methods like gradient boosting and XGBoost, demonstrating exceptional balance in accuracy and F1 score, achieving scores as high of 0.997 in both metrics. This indicates their robustness in class differentiations. The Bernoulli naive Bayes model showed limitations with lower accuracy and F1 score, mean score, suggesting it is less adaptable to this specific task. And other tasks, models such as SVC and our developed DMLPN also showed strong performance, particularly in detecting positive classes with high competence and F1 score. And this illustrates the potential of both traditional and deep learning approaches in complex environment. So thank you for your attention. We are welcome to any question.
Thanks for your presentation. So audience, do you have any questions? Maybe our audience. No? So we also don't have questions, isn't it?
Thank you very much for your very interesting presentation. We don't have any questions. Thank you.
Thank you.
Yeah, we can continue with ID 181. Himayet Hossain, MD Abdul Qayyum, are you here?
Yes. Can you hear me?
Yes, we can, but we cannot see you. Can you please turn on your cam? Okay. You have also 7 minutes. Please share your screen.
Hello, everyone. Good afternoon. I am Mohammad Abdul Qayyum from Bangladesh. Our paper title is Identifying the Coconut Leaf Disease Using Deep Learning Approach. Our co-authors are Himayat Hossain Tuhin, MD Rahmatul Kabir Russell, Shah, MD Tanvir Siddiqui, and Bishwajit Pandey from Astana IT University. Before starting our presentation, I want to show our presentation contents. That's our introduction, motivation, previous work, methodology, result analysis, and conclusion. Let's start. First, I want to talk about background study. Coconut is one of the main economic crops in Bangladesh. It is a tree whose every part is useful in one way or another in public life. It provides producers with a consistent income stream on a regular basis. But pest illness and nutrient deficits have an impact on the majority of the tree leaves. The disease of coconut leaves are bud rot, leaf root, stem bleeding, WCL, WD yellowing, WCL, WD flaccidity, CCI caterpillars, tip browning, etc. To detect the leaf disease at an early stage, 3 common diseases are widely found. There are WCL, WD flaccidity, WCL, WD yellowing, and CCI caterpillars. Our work. First, we apply data preprocessing like resize, rotation, shuffle, and after that, we train different types of deep learning models to predict coconut leaf disease at an early stage. Motivation. Most of the farmers are unaware. They do not know what kind of measures to take in the case of any disease. To address this issue, we train deep learning models to detect a disease at early stage. Farmers will benefit from these suggested methods faster, more efficient, and time-saving identification of leaf disease. As a result, farmers will be interested in cultivating coconuts. Previous work. Using deep learning for image-based different degrees of ginkgo leaf disease classified by Lin et al. They developed deep learning techniques and utilized 2 specific convolutional neural network, namely Inception V3 and VZZ96. For the purpose of classifying various degrees of ginkgo leaf disease, after preprocessing and training with a substantial number of images, the VZZ-net16 model obtained the greatest precision in laboratory condition. Meanwhile, the Inception V3 model obtained the greatest precision in field condition. And another one, identification of plant leaf disease by deep learning based on channel attention and channel pairing by Chin et al. They want to put CapNet on field robots and robotic flying vehicles in the future, so that they can build an automatic tool for supporting disease with low cost of interfaces. Researchers will also want to use transfer learning to make the model better at spotting plant disease in other species, which would improve precision farming. And another one is computer vision framework for weed disease identification and classification using Jetson GPU infrastructure for Roisa et al. The study focused on the adverse effects of a disease on crop prediction, particularly in wheat. This study implemented deep learning models like ResNet50, Inception V3, VZZ16, and VZZ19 to automate plant disease identification. The VZZ19 model achieves the highest accuracy in wheat disease classification with the use of advanced deep learning techniques and image data. The automation of plant disease diagnosis has great potential for enhancing crop management and production. Dataset description. Our data is collected from Kaggle dataset. Dataset has 3 major diseases affecting coconut leaves with total 3,166 photos, where caterpillars have 1,004 images, flaccidity has 1,071 images, and yellowing has 1,091 images. We divide dataset as 70%, 20%, and 10% for training, testing, and validating accordingly. And you can see the table here. We define what number of images are in the class. Methodology. First, we input the data in model, then use data processing like resize, rotation, zoom, flip, and then we split our data, train, test, and validation, and we apply the different types of model like Inception V3, MobileNet V2, VZZ19, and ResNet50. After applying algorithm, we evaluate our performance and comparison the performance, and we make a decision. And after that, we analyze the result. As you can see in the bar chart, here we can see we use 4 models: VZZ19, MobileNet V2, Inception V3, ResNet50, and we get the same accuracy, that is 96% in VZZ16 and MobileNet V2, and 97.7% in Inception V3, and we got the highest accuracy, that is 99.3% accuracy in ResNet50 model. Conclusion. Coconut cultivation is a significant sector in Bangladesh. It provides producers with a consistent income stream on a regular basis. The major goals of this study is to provide farmers with an advanced agriculture guide that will help them quickly identify coconut leaf disease. It looks at the entire procedure for detecting disease connected to coconuts. Before classifying the picture, this study worked on segmentation and feature extraction method. Initially, multiple algorithms are applied to be checked for more accuracy. Algorithms are ResNet50, VZZ19, Inception V3, MobileNet V2. This study concludes with a suggestion for deep learning models based on RISC-50 that detects coconut leaf disease at their early stage. That's all our presentation. Thank you.
Okay, thank you very much. Do you have any questions, participants, audience? Okay, thank you very much. And here I have some questions. So related to your previous works, you applied here another functions, yeah? And did you see here any differences in accuracy? You showed us in the last pages for comparative analysis, and how do you think? So sorry, my question is like this: which function is more effective? Does it depend on the types of models? Do you understand?
I cannot understand your question, please.
Okay, at the end of the presentation, you showed 4 different your functions applied. Yeah.
Yes.
And here with different accuracy. Yeah? And here, does it depends on the types of models?
We apply same epoch on the data on the model, and we get the accuracy like this.
Mm-hmm. I mean, for your model, it's good. So we see these results if we apply these functions to another model. I mean, not related to your models. So is it general description of these functions or no? Can we have different values of accuracy in related to different models?
We apply different model like VGC16 and others, so we got the like accuracy like 90% and 80%, something like that.
Okay. Thank you very much for your interesting presentation.
Thank you so much.
We need to continue with ID 188, Volodymyr Levitsky. Are you here?
Good afternoon, I'm here.
Could you please turn on your camera and you can share your screen?
Can you see me?
Yes. You have 7 minutes. Good luck.
Thank you. Can you see the presentation? The theme of my paper is use of deep learning methodologies in combination with reinforcement techniques within autonomous mobile cyber physical systems. Introduction. The widespread integration of information technologies has significantly boosted the complexity and autonomy of cyber physical systems across diverse domains. Mobile CPS has emerged primarily due to extensive use of personal computers, smartphones, and multifunctional wireless devices, forming an interconnected ecosystem. In the realm of information technologies, swift calculation and ample task processing resources are vital for CPS efficiency. Establishing network connections between mobile systems and server or cloud environments is a common approach to swiftly deploy nodes in autonomous mobile CPS, facilitating the execution of complex tasks beyond local resource constraints. Recently, there has been a rising trend in integrating AI methods, particularly deep learning algorithms, to enhance CPS, including mobile systems. This integration can lead to more precise decision-making, optimized resource utilization, and overall system performance improvement. AI-powered mobile CPS can adapt to dynamic environments and learn from past experience to enhance their performance. The objective is to thoroughly analyze the implementation of deep reinforcement learning in autonomous mobile CPS. This analysis will explore various integration methods and identify potential areas for improvement in autonomous mobile cyber physical systems. that can benefit from deep learning. Proposed options will include reinforcement learning techniques to enhance decision-making. Ultimately, recommendations will be provided for effectively incorporating deep learning technologies into autonomous mobile CFS. Issues of CFS. Accurate data management in autonomous mobile CFS hinges on achieving time consistency between physical objects and their digital representations. While mathematical models are employed for creating digital replicas, simulation times can exceed physical processes, leading to data unreliability. Advanced methods like deep learning or DRL expedite calculations while maintaining simulation quality. Software security is a paramount concern, especially in safeguarding against cyber attacks on wireless communication systems. With increased reliance on wireless communication, systems become more vulnerable. Responsive and adaptive protective mechanisms, often utilizing machine learning such as DRL, are proposed solution. Continuous learning enables real-time detection and prevention of cyber attacks, ensuring system security. Optimizing mobile CFS performance requires a thorough understanding of the operating environment and component processes. Sensors and detectors serve as sensory organs gathering crucial data. Algorithms like deep learning and DRL enhance sensing capabilities, for example, processing gestures using a Wi-Fi model. By analyzing data from various sensors, these algorithms enable more efficient and intelligent operation, leading to improved performance. The principle of operation of cyber physical system. The interaction between CFS and its surroundings is a crucial aspect that needs to be emphasized. It is essential to identify the primary components of CFS and how they work together. The autonomous CFS operates in two different spaces simultaneously, cyberspace and physical space. Cyberspace is the digital realm where artificial cybernetics elements such as digital representation, computational models, algorithms, and the virtual environment exist. On the other hand, physical space or environment is a tangible world where physical objects are located and real-world processes take place. To achieve its objectives, the CFS needs to navigate between both cyberspace and physical space, seamlessly interacting with them. This interaction between the digital and physical realms lays the foundation for the functionality and operation of autonomous cyber-physical systems. This is a generalized structure, CFS, and its interaction with environment. CFS operates by receiving three inputs at its entrances that are essential for its functioning and operation. The first input is input data, DX, which comprises all possible variants of input data. This input is critical for CFS to collect information from environments such as temperature, pressure, humidity, etc. The second input is the command CX, which is a set of commands. This input is essential as it allows the user to interact with the CFS and direct it to perform specific tasks or functions. The third input is the current state of physical process, SP, which is set of states. This input facilitates the CFS to monitor the state of physical process, such as position of a robotic arm or as the speed of a conveyor belt. Similarly, the CFS generates two outputs at its exit. The first output is output data dy, which is a set of all possible variants of output data. This output provides information about the CFS actions. The second output is a guiding influences AP, which is a set of guiding influences. These guiding influences are critical for the cyber physical system to make decisions and perform the task effectively. Overall, the inputs and outputs of the CFS is a crucial role of enabling it to interact with the environment to perform the designed tasks and functions. On this slide, we can see a generalized structural diagram and of control system with DRL model. DRL, reinforcement learning is a type of machine learning where an autonomous program or agent learns to make optimal decision to achieve specific goal by interacting with its environment. An agent learns by engaging with the environment in an iterative process of taking actions and receiving feedback. This continues until the agent learns the optimal sequence of action to achieve the desired outcome. Reinforcement learning comprises various algorithms with their own ways of learning, but all aim to help the agent interact with the environment. This is done through a trial and error approach, as the agent tries to determine the best actions based on observable or partially observable state of the environment. DRL is a combination of reinforcement learning and deep learning methods that use neural networks. It involves computers analyzing large volume of input data to determine an optimized paths or actions. DRL has shown promise in solving complex problems like playing games and controlling robots, and has the potential to revolutionize many fields. DRL uses deep learning to extract features from complex data and then applies reinforcement learning to make decisions based on these features.
Sorry,
proposed option for using.
Yeah, it's already 10 minutes. Vladimir?
I'm sorry, the presentation is very big.
Yeah, so thanks for your presentation. So it's already 10 minutes. So do we have any questions from the audience? I think there is no question. So thanks again. So I think we can continue with the next speakers.
Thank you.
So the next ID 189, Aybagarov Serik Aksultan Muhammad.
Hello.
Hello. Could you please turn on your camera and share the screen? And also you have 7 minutes to present.
Okay. Hello everyone, my name is Aksultan Muhammad. I'm PhD student in Kazakh National University Almaty. Our topic is predicting oil recovery coefficient with machine learning methods on data generated from the Bakre-leveled model. In this work, we developed and applied machine learning models to predict oil recovery coefficient to improve the efficiency and the environmental impact of oil extraction strategies. Our key goals is addressing inefficiency in oil extraction, predicting oil recovery coefficient to optimize resource utilization for reducing environmental and economic impact. In this work, we use machine learning algorithms to predict oil recovery coefficient. Oil recovery coefficient using in oil production problems. For this work, we use Bakre-leveled model. You can see this Bakre-leveled mathematical model in these main parameters which we use in our work. It is W, it is saturation, and main variables is viscosity, velocity, class, time, and eta. Eta, it is oil recovery coefficient. We predict this coefficient using other variables. Our dataset size is you can see in this our dataset size for using this mathematical model. We collected dataset. Second is our correlation of variables. In this figure, you can see correlation features. It is main. You can see this main basic variables in our dataset. We're using eta for predict and
Sirik, are you here?
So dear participants, can you hear us?
Yes, we can.
This is his problem.
Aksultan, are you here? Aksultan, could you please share again your screen? I think we cannot see.
In this, we use MSA, MIA, and MBA. This mind biased error matrix. You can see these main results. We can get in train and test dataset in very bad results in our dataset. Have to in linear regression and other dataset, other algorithms, random forest, and artificial neural network shows very good results. And in this, you can see our plots, cross plots in our each algorithms. It is its cross plots. You use test and the train dataset. Train that and test dataset. Yeah, is straight line in this. It is our predict data, and you can see in random forest and the neural network shows very good results. But linear regression shows very bad results than other algorithms. And second, this is the residual plots in our each algorithms. It's also train and test data in our each algorithms. You can see in this our predict results. Also, neural network shows very good results than other algorithms here. For example, in this we using before each algorithms you using bridge search CV. It is optimization methods for our each algorithms. And before optimization, our algorithm shows very bad results. For example, random forest and XGB regression shows 75, 80% R squared. And after optimization, neural network and the random forest matrix showed 99% R squared matrix. In conclusion, you provide we can accurately predict oil recovery coefficient using machine learning models, using 5 models. Accuracy of all evaluated algorithms was over 90%, with the top performance achieving error squared values above 99%. In future works, we will use more complex mathematical models. For example, black oil, it is also oil models or statistical models for our for in this work, and other simulators or GPU or parallelism for this to predict, to get good results and get to very good training time for our work. Yeah, that's all.
Okay, thank you very much. I have, sorry, do you have any questions, participants? No? Okay, I have one question here. I want to ask about your inputs. What kind of inputs did you put in your machine learning to test?
To test that, because in this I forgot to put our dataset in using Berkeley level mathematical model. You get values with viscosity, porosity, cavities, and this dataset, these variables you take as input data.
So here you said that your function depends on T as we see in your model. So your dataset size of the 403,444, it means your time for these 6 parameters, yes?
Yeah.
Okay, in this case, by implementation of ML function, am I right that you are calculating analytical solution?
Yeah.
Okay, thank you.
Other questions?
So one more question here, as from machine learning, what kind of function did you use here?
Which function?
The last one, artificial neural networks. Okay, I see here.
Thank you.
Okay, thank you.
So I think we can continue with the last. I think we can continue with the next paper, ID 197, Yuri Yashuk, Yulia Yurchenko, yes? I think yeah. So you can share your screen presentation and you have 7 minutes to present, okay?
Okay. Can you see my screen?
Yes, we can.
Hi, everyone. My name is Yuliana Yurchenko. Me and 3 other authors, Yuri Yashuk, Natalia Yurchenko, and Yuri Andrashko, were investigating the influence of synthetic training data on optical character recognition based on SRO-IE dataset. While receipt OCR demands significantly higher accuracy levels than general OCR tasks in numerous commercial applications, it still remains comparatively understudied. In this research, we aim to generate synthetic images that mimic receipt text images from SRO-IE dataset and investigate effect of such synthetic data on the training of a neural network for OCR tasks. SRO-IE dataset consists of almost 1,000 images and is divided on training and test parts. Images represent scanned receipts. Some samples you can see on figures A, B, and C. The images exhibit significant defects like stains, abrasions, glare, blurriness, noisiness, and have various text colors, sizes, and fonts. Figure 1D shows a visualization of annotations, which for each image describes a set of bounding boxes and ground truth text inside them. To simplify the OCR task, we cut images from SRO-IE dataset using their annotated bounding boxes, and then obtained a new dataset of single-line text images with annotated texts. This set is the one we use for our experiments. We propose an approach to creating synthetic text images. It includes several steps. The first step involves overlaying text on a white background. Actual texts were taken from annotations of the training original dataset. The main parameters for creating text images with a white background are listed in table 1. In the second step, we added distortions to images via applying noise functions, blurring, and rotation operators. Applied transformations have random intensity, and creating that data this way allows getting labeled images of texts in any quantity. Some samples of generated synthetic images are shown here on the slide. We built a convolutional recurrent neural network and used it for OCR tasks. The architecture of the neural network you can see on the screen. Also, program code for generating synthetic data, training the neural network, and recognizing texts is written on Python with usage of these libraries. As a metric for OCR task, we used relative Levenshtein distance, which is a type of edit distance. During our experiments, we trained 3 versions of the same neural network. First was trained exclusively on synthetic training data. Second, exclusively on original training data. And third, with transfer learning approach, which means pre-trained on synthetic data and then trained on original data. Table 2 shows the results of testing these models on a test dataset of single-line text images. By analyzing the results, we conclude that synthetic dataset has less variability of fonts and random defects. Although the transfer learning approach surpasses training solely on original data and reduces relative Levenshtein distance by approximately 32%. And this result proves the benefit of using synthetic data in practical OCR tasks, especially in the case of insufficient number of original text images. In conclusion, in this study, we created a data set of synthetic text images to mimic text lines from SRO-IE dataset, trained dataset. We built CRNN for OCR task and did experiments to evaluate the effectiveness of using synthetic training data. According to our results, synthetic training data play a crucial role in improving OCR model performance. That's all from my side. Thank you for attention, and you feel free to ask some questions.
Thanks for your presentation. So, audience, do you have questions? So I think there is no question. Juliana, thank you.
Thank you.
Presentation. So, and we will go now to coffee break with offline participants, and we will continue at 16:20 after 18 minutes.
Thank you very much.
Thank you, bye.
Okay, dear participants, we have a participant who is from Kyrgyz National University, Professor Nelia Akalbekova. Nelly, are you ready to present?
Yes, yeah, I'm ready. Can I show my?
Thank you. Please turn on your camera and please share your screen.
Sorry, a moment. I can show my presentation. Just. Can I present this without presentation?
I'm sorry.
I came to setting my presentation.
You have no your presentation right now?
Yeah, I have. I can to show you. I can.
Okay, Nelly.
Wait, no. Do you see my presentation?
Paper number 198 here.
Yes.
Rustem Imambek.
Yes.
Жолдас Прибай. Nelly, if we give you some minutes and now listen Rustem Imambek, Жолдас Прибаев.
Yes, of course. Yes, of course.
Okay.
Sorry, yes, of course.
Rustem, please start your presentation, share your screen and turn on your camera.
Okay, first of all, I want to know, can you hear me well? Can you hear me?
We hear you, but we don't see you.
Okay. It's not problem.
Okay.
First of all, I just want to ask first, can you hear me well? No. If you can hear me well, so it's excellent. Just give me a second. I'll share my screen. Can you hear my? Can you see my screen?
Okay, that's good. Start, please.
Okay. So hello everyone. My name is Imambek Rustem. I'm one of the authors of our sorry, I have some problems. I can't hear you. I don't know why.
Ну, вы же на сумме умеете, да, презентацию показывать или нет? Нет,
No, it's good. I know it. Sorry, it's technical problems.
На сумме не могу презентацию
So,
показывать.
yeah.
Ну, ладно. Я так конфликтую.
Okay. So, hello everyone. My name is Simon Bekristim. Sorry about the technical problems. Now problem solved. So I'm one of the authors of
What kind of problems?
With computer was some lagging. So maybe you could see my presentation, but I couldn't.
Just a moment.
Now problem solved. I can continue. So can I continue to present? Can you hear me? Can I continue to present?
Rustem, please start.
Okay. So hello everyone. My name is Iman Betrostim. I'm one of the authors of our conference paper. So the conference paper title is HRVWSD, which stands for Hybrid Radio Based with Standard Deviation. So in the study, imbalanced medical data were used, which were taken from the InvaLearn dataset library that is in public access. Table 1 shows the full description of the datasets. So as you can see from the table 1, we used thyroid-seq, mammography, and arrhythmia medical datasets, and you can see the full descriptions of these datasets, objects, features, and ratio as well. So on this slide, you can see the principle of operation of the hybrid algorithm. So at the input, we have the original imbalance data that goes to hybrid algorithm. The hybrid algorithm consists of two parts: RBU with standard deviation modification and RBO with standard deviation modification plus modification drop duplicate function. So first our data goes to RBO with standard deviation, which removes objects until the difference in standard deviation value is less than or equal to 1. Then our data goes to RBO with standard deviation plus the drop duplicates, which generate objects until the difference in the standard deviation value is less than or equal to 1 as well. And also drop duplicates function is used to take into account minority data duplication. And at the end, we're gonna get fully balanced data. So on this slide, you can see the list of the advantages of a hybrid algorithm over other radio-based algorithm. To be exact, HRVWSD or hybrid algorithm combines both principle of balancing, undersampling and oversampling. Also, hybrid algorithm takes into account the original data distribution when RBU and RBU don't. And also, RBU doesn't take into account minority data duplication because it's just undersampling technique that it removes objects of the minority class rather than generating minority class objects like RBU, but hybrid algorithm does take into account minority data duplication. On this slide, you can see the pseudocode of our hybrid algorithm. This study proposed a hybrid algorithm HRB-WSD to address the problem of class imbalance in medical dataset. So the main improvements in this condition, if this condition are satisfied, then only then majority objects from majority class will be removed in other sampling technique, and the same for our sampling technique. Only then minority class objects will be synthesized. And also we provide drop duplicate function, which checks the synthesized string from duplicates. If any exists, then it will be deleted. The results of experiment showed that hybrid algorithm provides comparable results with other class balancing methods. An important aspect of the study is the use of non-linear UMAP algorithm for data balancing visualization at each stage. This allowed to clearly demonstrate the effectiveness of hybrid algorithm compared to class balancing method. And at table 3, you can see the comparable results of hybrid algorithm to other class balancing techniques. And at figure 3, you can see each visualization of heuristic data set, which we with hybrid algorithm who was
2 minutes left.
Okay, so at table 5 you can see the same result, but for arrhythmia classification, for an accuracy of hybrid algorithm, as I said before. First it starts from a region that is distribution, then it goes to RBU, then it goes to RBU, and at the final step you can see the hybrid algorithm distribution. And for mammography dataset, the result is the same. You can see the comparable results and implementation of hybrid algorithm of each step of hybrid algorithm. And thank you for attention. If you have any question, please ask.
Thank you very much, Rustem. So one question, how many features are in your data set?
We get three, we have 3 data sets. You can see how many features you can see in this slide. So thyroid has 27 features, mammography 6 features, and arrhythmia 278 features.
So your picture on the last slide have only 2 dimensions. So I think that you use some techniques to reduce feature set.
Yeah, we used UMAP.
Okay, thank you very much. Any questions, please? Not questions. Thank you very much. So the next presenter is ID 205, Bekir Oku Durlar, Ibrahim Shaya, Asiya Sarimova, Ibrahim Yassizi. Are you ready?
Yeah, I am ready. Yeah.
Okay, share your screen and turn on your camera.
Okay, thank you. I'll share whole screen. Is it okay? I think you can see my share. It's okay.
Yes, we can see. Thank you very much.
Okay, I am İbrahim Yazıcı. I will be presenting a machine learning approach for predicting temperature and precipitation patterns titled paper. And my co-authors is Bekir Özardır and İbrahim Şahya from Turkey, and the other Asya, Professor Asya from Kazakhstan University, as I know. And in introduction, we'll be doing climate modeling with machine learning in this paper. Climate modeling is one of the landmark important topics in the literature. This research explores the integration of machine learning techniques into climate modeling, aiming to develop a simplified model for predicting temperature and precipitation based on location and time. In the paper, we are using machine learning to predict climate in US regions, in two regions in the US, West Coast and East Coast. And climate data in the paper, climate data were first obtained and processed, and then different features were extracted and used for experimentations to deploy artificial neural networks. This is neural networks. After various settings with different features were experimented in the paper, the final model exhibited improved accuracy with mean absolute error decline, and this decline was given also in the results. In the paper, we utilize publicly available data in the link for the application. This regular climate data you can easily obtain from the internet, and it contains average monthly data from many cities. It will be better than average daily data using from a few cities. And after all, our goal is not to predict tomorrow's forecast, but it is to make a reasonable weather assumption given the date and location of a place. These places are, as I mentioned earlier, the US East and West Coast two cities. With the aim of creating a unified data set for each city, we first collected data for each city and then cleaned the data, finally conjoined to obtain a unified data set within US data. Firstly, we collected the US East Coast data and then checked whether the data set was correct or not. And then we created a correlation matrix to see the relations between our features, because we are using machine learning and the correlations between the features are very important to model our climate data. In the implementation stage, we try to build one model with two outputs, temperature and precipitation with our input set. This is the basic model, basic machine learning model. Then we iteratively try to find the best model for the prediction by tuning hidden layer sizes. The most important aspect in these trials are the tuning hidden layer sizes. And then we train the model with a backpropagation algorithm. This is a popular algorithm for training the neural networks. And as an example, we will show the prediction for the weather in each month in two USA East Coast and two USA West Coast, but these are in the paper. We are representing Savannah City from the West Coast and New York City from the East Coast with the simplistic model. And we can see the predictions here, predictions for temperature and precipitation, and the actual values as expected temperature and expected precipitation. There are differences here, as we will see the improved results in the later slides. These are given as per each month. You can see the differences for Savannah City, and for the New York City, this is the East Coast city of the US. And then by looking at the results, we restructured the models. In the light of the obtained results and the information, we modified our model. We tried to add some steps to obtain better results as seen in the following. First of all, we expanded our data set with adding more different climate zones, included data from Southern America. And then we don't feed elevation into model. Most of the data is from flat regions, so it just confuses the model. New input is important. We added dummy variable for the cities. If this is in the west, it is one is used for the west, and then if the city is the east, and then as a label 0 is used. This like a binary coding for the east coast and west coast. And new input continentality, proximity to large bodies of water. If you are in degree in radial, if you are proximity to large bodies of water, it will be used for the city with the formula sine.
1 minute left.
Okay, and then we restructured the models, and after extensive trials, we obtained these results. The best one is with 1 hidden layer and 2 neurons. And these are the results. And these are also improved results with our restructured models. In conclusion, final tuning for the neural networks resulted in better performance as per mean absolute error metric by the values for temperature and precipitation respectively. Machine learning used in climate prediction makes promise for further research as per our conclusions. The model can be expanded into day-to-day prediction by using powerful deep learning methods such as recurrent neural networks. These are very good at forecasting time-oriented data. And finally, incorporating the powerful deep learning methods will likely result in better outcomes for climate problems in big data regime. Thank you for listening. Feel free to ask questions if you have any questions.
Thank you very much.
Thank you.
Babakurovna, do you have any questions?
Yeah, one question. Do you hear me?
Yeah.
Okay. It's a very interesting presentation, but the quite important thing is what kind of features did you include in your prediction model? How many features were included into your system? And
Okay.
about your new feature number 3, when you use the sine function, you mentioned that this function must change between 0 and 1. It looks like something artificial. Is it possible to use just linear function between 0 and 1? Maybe it was just your different choice.
This is a categorical variable. Like 1 represents the east coast and the 0 binary categorical representation, not a continuous variable. We included it to represent our east coast and west coast. And also, our in the first stage, our features were precipitation. You see from my screen, temperature, sun power, and latitude. And we added here the.
Thank you. I see it from your screen. Yeah, latitude. Yeah.
Yeah, we added the other
sun power, temperature. Okay.
Yeah, we extended our feature set by restructuring our model. Data expansion is one of the options. It is okay. We did it, and then we restructured the model by extending and increasing the hidden layer sizes. So we improved the results.
Thank you very much. So next presenter.
Thank you.
Welcome.
Number 219, Dilara Abzhanova, Sapar Toksanov. Please share your screen and turn on your camera. Okay, we can see you. Baturbek.
Yes, hello. So let me share my screen. Just a moment. Can you see my presentation?
Okay, all is good.
So let me start. So my name is Vakhtiro Baturbek. I would like to present the article development of database for the main stationary sources of pollution with regulation of emission codes. So let's start. So to begin with, advance in various fields like industry, economics, education, medicine, and ecology are largely driven by digital technologies. So in developed countries, including Kazakhstan, there are government programs aimed at enhancing these technologies. So this is called a digital transformation, which is more becoming increasingly important. So in July 2023, the president of Kazakhstan, Kassym-Jomart Tokayev, highlighted 5 main goals for this transformation, including developing a digital economy and Industrial 4.0, which represents the latest industrial revolutions, focused on using modern technology to improve industries. So a significant part of this shift is the creation of smart industries that use modern technologies to make production more efficient. So main goal here is to reduce environmental impact, specifically aiming to eliminate emissions like carbon dioxide from industries. So to manage pollution effectively, it's important to have systems that can quickly gather accurate information on emission from industries. So it can be solved by developing automated systems that can monitor, collect, and process environmental data. So implementing blockchain technology into these systems can help make the data more reliable and secure by creating unchangeable records. So blockchain technology offers several benefits for this management. It allows for a precise tracking of emissions and carbon footprints. It helps verify the use of renewable energy resources. It can automate the enforcement of environmental regulations through smart contracts. So to build a system for monitoring and managing air quality, it's important to understand how to handle risks and uncertainty and to use intelligent information technologies. So the process involves 3 main activities: monitoring the environment in the real time to assess conditions, auditing these conditions to ensure they meet specific standards and regulations, and making management decisions based on this information, and then checking their effectiveness. Incorporating modern Internet of Things, IoT technology, is important. IoT sensors gather real-time data on various air quality indicators such as pollutant levels and meteorological conditions. So this data is sent to central database for analysis, providing a comprehensive understanding of air quality. However, handling the large volumes of data shows some problems, including ensuring privacy, maintaining data integrity, and keeping the data accessible at all times. There are also risks of malicious attacks and the need for efficient resource management. To mitigate these problems, integrating blockchain technology can be very effective. It ensures that data is immutable and secure, enhance the security of data storage, and uses encryption to protect the data confidentiality. So it also enables transparent and automated processes such as emission trading and compliance with environmental standards through the use of smart contracts. So the conceptual model shown in the figure, it integrates blockchain technology in IoT devices for monitoring environmental emissions. It begins with using sensors in factories to collect data on air quality, including the levels of harmful substance, temperature, and humidity. So this data is then recorded on the blockchain at the next level of the model, ensuring that the information is secure, cannot be tampered, and it's also transparent. This makes data highly trusted because each piece of information added to the blockchain is linked to the previous one. And so it makes any falsification of data require altering the entire chain. Also, smart contracts are used to automatically check that the data meets environmental standards, and the results of these checks also stored on the blockchain. At the third level, the model processes and analyzes the data. So this processed data is then used for decision-making at the client level, where the solutions to improve air quality are proposed based on the analysis. Also, the database is a key part of the system. For this project, PostgreSQL has been chosen because it's powerful and flexible. Also, PostgreSQL is very reliable for storing large data. It has sophisticated good features for transactions, replications, and recovery that help keep data safe. So the database information accumulation process is a dynamic, so it's showed in this figure. So data enters at rate AT and exists at UT, both rates following the Poisson distribution. So this creates a Markovian system with continuous time and discrete. So the environmental monitoring system tracks pollutant emissions from primary sources, measuring key indicators and transmitting data in real time as per period. So these systems models helps manage database information, detect unauthorized systems, and save the data against unauthorized access. Also, Internet of Things approach is suggested to monitor air quality across multiple locations. This method incorporates IoT devices and utilizes big data techniques to analyze patterns, providing essential information for effective environment monitoring and protection. So this is all. That's all. If you have any questions, you can ask.
Thank you very much. Have any questions?
Yes, I would like to ask.
Okay, please. Could you?
Thank you for your presentation. It's very interesting and novel idea. I would like to know how does the blockchain technology that you suggested in your paper provides the protection against external programmable attacks? So
blockchain makes sure that data cannot be changed and keeps it safe. It also protects the privacy of the data using encryption. Each new record on the blockchain is connected to the one before, so it means that changing any data would require changing the whole chain, making that data is secure and safe.
Thank you very much.
Thank you very much. So the next presenter in person, Gauhar Toktagulova, Aygul Mimbaeva. Please, in English. So, please start your presentation. Can you come closer? Okay. So.
I'm from Sarj, I'm from the City University, and my report analysis of machine learning algorithms for the concept data in Kazakhstan. For the abstract, I make a comparative analysis of machine learning algorithms for the forecasting the crop yields prediction in Kazakhstan, and I use such algorithms such as linear regression, lossy regression, rich regression, gradient boosting, etc. And key finding of this research is that linear models are outperformed others, achieving square accuracy of 95%. The next page. So introduction. So the purpose of this research is to enhance accuracy and predictability of agricultural yield forecasting using machine learning algorithms, and objectives is to develop these models for predicting crop yields based on weather parameters and effective planning. The novelty of the research that utilizes the extensive historical weather and wind data. In this machine learning model accuracy. So, from the literature review, this discussed the impact of climate change on several crop fields globally, emphasizing the temperature and precipitation changes affecting agricultural productivity and the human statement and other literature demonstrated the effectiveness of the machine learning models like running forests, producing crop fields based on laser data. And others discussing the role of data analytics in creating climate resilient in farming practices and related trends. This usual to integrate technologies. Next page. So, and the others are analyzed climate change on the impact of climate change on the global food security, following the urgent policy of international. Okay, so contribution to the current research that these studies currently emphasizes the necessity of using the analytics and machine learning tools to improve the ability and the accuracy of agriculture that comes directly informing the methodology and objectives of current research for applications because of agriculture. So methodologies I use two sets is historical data weather, and the second is crop harvesting data. And machine learning algorithms, binary regression of muscle, range regressions, and boosting decision learning, decision figure and policy, regression, and evaluation this diagram explains selection and processing, examining of training, testing, so the processing and releasing values, training data, and feature selection, so ensure the quality results. Transforming the best models training with integration methods. 1 minute left. Okay, I just described all the machine learning algorithms. Next page we can skip them. It's just a description of each and the very sense of my numbers. So this data process visualization, graphics that visualize data the time. This is a heat map that shows the correlations between the variables like profiles and the weather. So key insight is that profiles has a similar coefficients, but as environmental factors are like temperature and the precipitation. Aspects and the results
Please conclude.
The potential
Thank you very much. Questions, please. Almas. This topic is very real. Okay. No questions, please.
No questions.
This topic is very relevant to your master thesis. Okay. I have a question. What is the best machine learning algorithm for your research?
Go back into the results.
Okay.
Yeah, see that binary regressions of models, other binary regression regressions are just like slightly modified versions of this.
Okay, thank you very much. Please. Thank you very much. And the next presenter is Nelly Akulbaeva. Nelly, are you here? Nelly Akulbekova, sorry. Professor Nelly Akulbekova, are you here? Okay. Nelly is not here again. So the next, Gulnara Abitova, Mirasa Balkanov.
Hello.
Are you ready?
Yes.
Oh, thank you. Please share your screen and turn on your camera.
Okay, 1 minute. Okay, did you see my share?
We see, but you turn on your camera. Okay.
Okay.
Please start.
Okay, so this my topic of the article is comparative analysis of machine learning algorithms for fraud detection. So the author, my name's it's me, Mirasa Balkanov, and Gulnara Abitova from Astana IT University. Okay, let's move on. So I want to begin from introduction to credit card fraud detection. So the main problem is the card fraud is a major issue leading to substantial economic losses for consumers and financial institutions. So the objective is to apply and compare different machine learning algorithms to detect fraudulent transactions in credit card data. So I used algorithms like logistic regressions, a linear model for binary classification, decision trees, and nonlinear model that splits data into branches for decision making. And the last one is random forest, an ensemble method using multiple decision trees to improve accuracy. And the dataset is from Kaggle, a credit card fraud detection repository, which is consists of 400 16,000 transactions with 31 features, including a target column indicating 0 for legitimate and 1 for fraudulent transactions. Okay, so the methodology. So as I said, I used a dataset from Kaggle, and data processing is contain some methods. The first one is data collection, and second one, data processing, is about cleaning the data. So if there are some missing values, to ensure the data completeness. And the second one is feature selection, applied techniques to identify the most predictive attributes, enhancing model efficiency. And the third one is handling imbalance. So it's used synthetic mineral oversampling technique, smooth to address the skewed nature of the data towards legitimate transactions. And after that, I begin the data analysis application of statistical methods to analyze the data and model performance using sensitivity, specificity, accuracy, and error rates. On the next slide, we can see that the system architecture. So the first one, we are starting from read the dataset. And the next step is oversampling is done. Divide the dataset into the train and test sets. For the next is feature selection. In there, we're selecting the feature, logistic regression, decision trees, and random forest. Second, so the next step is prediction of outcome for test data and performance and accuracy results from the test sample data. So in the conclusion and future directions, I want to mention that in the model performance, GIF for logistic regression is 98.1% accuracy. Decision tree is 93.8% accuracy, and the random forest is the best. He gives 99.01% accuracy. So the conclusion, the random forest model demonstrated the superior performance in detecting credit card fraud compared to logistic regression and decision tree models. So also we can highlight the potential of ensemble methods in improving fraud detection accuracy. In the future directions, it could be address data imbalance. So it's continue exploring the advanced techniques like oversampling and undersampling to improve model performance. So explore additional algorithms, investigate other machine learning models such as support vector machines, SVM, and neural networks for potentially better results. And model updates, regularly update model with new data on emerging fraud patterns and continuously retrain to adapt to evolving fraudulent techniques. So thank you for your attention. That's
Thank
all.
you very much. Questions, please? Balgasha Gafurovna, have any questions?
No questions.
Okay, thank you. I have one question. So you used accuracy metric, right?
Yes.
So how much what is other metric do you plan to use in your future book?
Oh, in future book. Maybe it could be some CNN models. I think it's could be provide more detailed structure for algorithm, and for maybe in training it's more provide and better accuracy. So anyway, the random forest is good, I think.
No, I mean
for this kind of
evaluation.
problem.
Evaluation metric, not a model to train or not model to predict, just how many metrics do you know and what of them do you plan to use?
Oh,
Such
the metrics.
maybe recall, maybe precision or other metrics. Okay, thank
Okay. Uh-huh.
you very
So,
much.
yeah.
So the next presenter, Viktor Ladyzhets, Bogdan Yeremenko, Svetlana Terenchuk.
Yeah, hi. Hello, I'm here. Let me just share my screen.
All is okay, plus?
Yeah, I believe you can see my screen.
Yes.
Yeah, great. So I'm Viktor Ladyzhets, and I'm here to present to you our research on candidate generation for meal recommendation system. Before we start diving into the details, I would like to talk a little bit why are we doing the meal recommendation system. So we believe that technology is here to make our everyday life easier, and we see how it's already helping us with a lot of stuff online. We believe that, and we see that recommendation systems are deeply incorporated in our daily life. We use it every time we go to some search engine, when we're looking for media content, for news, we get recommended for any content from social networks. We load up a screen, and instead of wasting hours looking for what we need, we can find it in just a minutes. And we believe that this technology can be applied to meal recommendation, for meal planning, for everyday life. And that's why we're doing this research. We believe that it will be much easier to promote healthy eating habits when we remove this hard part of deciding and planning your meal for the week or for the month or for any period of time. And as we dived into research, we found out that healthy eating contributes a lot to life expectancy for every person. We believe that it can reduce decision fatigue. We all know this feeling when we want to eat something, but we don't know what, and we spend a lot of time and energy trying to decide what we want. We believe that this technology can help with that. And also we believe that more efficient and easy meal planning will reduce the food waste, which will benefit all the economy, the budget of people, and also our planet as a whole. In our work, we are presenting our interpretation of architecture for such a meal recommendation system. It consists of 3 stages. We will focus mainly on the first one in this article, and in future works, we are planning to implement state-of-the-art recommendation system for meals. So this proposed architecture consists of 3 steps. First of which would be candidate generation. It was first introduced by Google for their YouTube video search algorithm. So basically what we are doing in candidate generation stage, we are selecting much smaller subsets of data from some big, enormous sized possible items for recommendation. So for our system, for meals, we have a database with few millions of recipes. And it's very hard to find the best suiting one for algorithm on such a huge database. So on candidate generation stage, what we aim to do is to reduce this number to thousands of recipes, so we can incorporate more features of the recipes for more complex and detailed algorithms, which we'll be doing on scoring stage. So the second stage is scoring, when we take much smaller data set and we use other features of recipes. For example, we use all the ingredient list for the recipes. As we know, each recipe can have 10 to 20 to 30 ingredients sometimes. And if we would include all the ingredients in the recipes in the first stage, the algorithm would take too long to decide the best recommendation, and the results wouldn't be so great. So we divide these 2 steps. We firstly collect smaller data set and then continue working with the smallest data set in second stage. And at third stage, we do re-ranking when we apply additional filters or maybe some user features we know, we apply it to rank all selected during the second stage meals for users so he can see the most likely he would like at the top of the page. It's also possible to use a few layers on each stage. For example, for candidate generations, we can select some trend items, then we can select favorite for users with similar users. And then we just can combine all of them into one big layer. So for our candidate generation stage, we decided to use wide and deep model, also presented by Google. It's
2 minutes left.
Sorry?
2 minutes left.
Oh, sorry. Okay, I'll speed up a little bit. So basically, I will just briefly point out the benefits of it. It allows generalization and memorization. We use wide model to capture the user liking to other users. We use matrix factorization for wide model. And we also use deep model combined with a few hidden layers to capture more item specifics that user might like. For example, we divided all the meals for categories and we search if some user prefers some categories of food. Let me just present you some results. We compared this algorithm wide and deep for content generation with just wide model and just deep model. And we see that it performs better in almost in all data sets that we tried it in. Same we do with another metric. So we used root mean square error and we use mean absolute error for our metrics. We also compared this wide and deep algorithm to popular choice SVD that is used by Netflix for their recommendation system. And we found out that for our meal recommendation system, it performs better than this industry standard algorithm for recommendation. Yep. Thank you for your attention. If you have any questions, I'll be glad to answer them.
Thank you very much.
Thank you. I have one question. How do you input in your model some kind of regional standard habits or traditions?
Yeah, this is the one that I really wish to include it. The problem is for us right now is to find data sets that would include such information about user. So I would really love to include user demographics as an input for recommendation system because I believe it would greatly improve the end result. Problems that we run into that it's hard to find data set with such information because this data is private, it is protected by different laws. So it's our future room for improvement. We are looking for this data set. If you know any place we can find it, I'd be really glad.
Thank you. So the next presenter, Timirvan Mirmakhanov, Bogdan Savitsky, Yerbol Irgaliyev.
Hello, do you see me?
Yes.
What about sound? Do you hear?
Yes, all is okay. Please share your screen.
Now I'm gonna share my screen. Do you see the presentation?
Yes.
So let's start. My name is Bogdan Savitsky, and I'm here to present our findings from the study analyzing and responding to the spread of COVID-19. So me and one of the co-authors, Timirvan, will talk about the pandemic, which has reshaped our understanding of the global public health and the economic stability, highlighting the profound impact of social economic factors and particularly economic resilience. So as you see, our primary aim was to provide actionable insights and recommendation for policymakers. These are designed most likely to help in making informed decisions and effectively allocating resources, utilizing the relationship between such indicators, as I've mentioned before. So crucially, our research serves as a prototype for predicting the spread for future pandemics. And we offer a model that can enhance preparedness and response strategies for impending global health challenges. So in conducting our studies, we've got a structured approach to gather and analyze the data. And our methodology encompassed several key components, which are data collection, data preprocessing, data analysis, predictive modeling, and finally correlation analysis. So let's move to the first experiment. So in our analysis, we've pinpointed significant variations in the impact of COVID-19 across countries, which are strongly linked to the strengths of their economics and health systems. So our most significant findings here was the highlight of the critical importance of considering a variety of factors beyond healthcare capacity in managing pandemics results and effectiveness. So as you can see here, we have observed that nations with robust economic systems and well-prepared healthcare infrastructures were obviously more successful in mitigating the impact of the virus. Conversely, those with weaker systems faced greater challenges. This underscores the need for comprehensive pandemic management strategies that take into the economic resilience and health system readiness. Furthermore, we have identified effective strategies and noted specific challenges faced by different countries in managing pandemic spread. So to further understand the dynamics of COVID-19, we have utilized the heat map to represent correlation coefficients between various health metrics, such as economic indicators and population data. This allowed us to analyze the strengths and direction of the relationships among key variables, such as confirmed cases, deaths, recoveries, active cases, GDP per capita, and population sizes. So several key correlations is like strong positive correlations, and they were most likely observed among COVID-19's health metrics, such as cases, deaths, and recoveries, indicating that these variables often increase together, which is consequently. So then we'll talk about weak positive correlations between GDP per capita and confirmed cases suggest that if it increases in cases and deaths occur as economic status rises, which is also consequently. And the last one is weak to moderate negative correlations. It is between population sizes and COVID-19 metrics, which indicate that larger populations might experience lower infection rates relative to their size, possibly due to factors like higher vaccination rates or better healthcare infrastructures. So as for our model to forecast COVID-19 infection rates, we have developed a predictive model using linear regression defined by the equation y equals mx plus b. Here, GDP per capita, which is x, predicts the number of cases y with m as a coefficient and b is intercept. We validated this model statistically, focusing on mean squared error, which is MC, and root mean squared error, which is RMC. The result depicted in a scatter plot here, as you can see, show a close alignment between predicted and actual case forecasting models, enabling more effective preparation and response strategies. Now let's explore how we can apply these insights to future public health planning. In regional correlation analysis, we investigated pairs of countries within WHO regions to identify strong correlations in daily new COVID-19 cases. And by utilizing statistical methods, we calculated correlation coefficients for daily new cases between countries within the same WHO region. So as you can see on the table, it presents us that countries like Algeria and Angola in Africa and Singapore and South Korea in Western Pacific with high correlation coefficients. So it means that these strong positive correlations indicate similar pandemic trends within the regions, suggesting shared or similar public health responses and epidemiological characteristics. So this analysis aids in understanding regional dynamics of COVID-19 spread, providing insights that we could enhance coordinated public health strategies across countries sharing similar pandemic patterns. So the next step in our analysis is visualized here on figures 5 and 6, and we have observed significant data on of the impact of COVID-19 and vaccination efforts. On the figure 5, we can see that the severe toll of the pandemic, with the United States recording an unprecedented over 103 million deaths, followed by Brazil, India, Russia, and Mexico, which also reported significantly high fatality numbers. Meanwhile, European countries such as United Kingdom, Italy, France, and Germany have experienced substantial impacts as well, indicating the broad and severe effects of the pandemic across these regions. So let's move to the figure 6, which focuses on vaccination efforts, showing that Gibraltar here leads with nearly 350 vaccinations per 100 people by March 2021. Following closely are Chile and Cuba with strong vaccination trajectories, as you can see. And despite having the lowest initial rates, both... Okay. So drawing from our analysis across various aspects of the COVID pandemic, we have uncovered the social economic effects, which underscore the disparity in case distribution and patterns across ongoing and future health crises. Moreover, our findings emphasize the essential role of the information technology and data science in managing pandemic responses. It has proven indispensable in tracking disease spread, analyzing data, and facilitating communication among health professionals and the public, underscoring the need for continuous innovation and preparedness in health technology systems. So in conclusion, the insights gained from our research not only provide a deeper understanding of the current pandemic, but also form a framework for predicting and managing future epidemics as well. By leveraging economic indicators, health data, and technological advancements, we can develop a proactive approach to public health, which will inform, adapt, and equip to handle the challenges of the future global health emergencies. So our approach ensures that will be better prepared with effective strategies in place.
Thank you very much. Thank you very much, Bogdan. We see questions, please. I have a question. Can you show us slide number 6?
This one?
Yeah. So 0.06, it is not a weak positive correlation. It means no correlation.
Yeah, but we counted. We didn't count this weak positive correlations in our research since some data sets we couldn't be sure can we handle this information because some of them are corrupted or not clear. So we have used in our research only strong positive correlations and encountered only this one.
Thank you. So the next presenter, thank you, Bogdan. The next presenter, Aldiyar Saken, Sultaniyar Kuandik. Please come.
Hello. Can anyone wait? Does everyone can hear us? Okay. So hello everybody. Okay. Can you see the presentation, everyone?
Yes, we can see.
Okay, well, good afternoon to everybody. First of all, I want to congratulate you with the huge event in our university. This is the fifth year anniversary of our Astana IT University, and we're happy and very pleasant to be here and share this opportunity and experience with you. So our topic, okay, let's get started. Our topic is developing a kind of question answering model standing on the shoulders of multilingual giants. In other words, we can see that it is development of a natural language processing based on Kazakh language. You can see the simple outline. So today we will talk about problem, research methodology, evaluation results, development of user interface, further research and achievements as well.
Okay, then why we decided to choose this topic? This is well-known knowledge that that Kazakh language is considered as slow research language. It means that it is hard to find ready datasets in Kazakh language to build any natural language processing model. That is why our solution, here's our solution, and the topic is about solving this problem for creating or question answering systems. Can you move on to the next slide, please? Okay. Thank you. Okay, talking about the research methodology, this is our method that we use in developing our model. As can you see in the timeline, the first thing that we did is collect the data set. We collect two data sets. First is a set of lazy corporate data set where we can where the stored tokens for Kazakh languages that collect from the Kazakh news, and the second is translated into the Kazakh languages standard data set for question answering systems. And then about how we fine-tuned the model. First thing that we did is we translated Squad into the Kazakh language, and then we have T5 model developed by Google. He has the function of fine-tuning question answering system, and that is why our task was to fine-tune this T5 into the Kazakh language and generate Kazakh T5. So the solution is, first thing is to use Kazakh Squad to fine-tune the T5 model, and then expand the number of tokens from the T5, because T5 has unsatisfactory amount of tokens, so that's why we use the latest corporate dataset to increase the number of tokens in our system. So finally, we get the product model that accepts context. Can you move to the previous slide? That accepts tokens or context and question and generates the answer dependent on context. So talking about this methodology is pretty universal method, because by using this method, this approach, we can generate any language model for Kazakh language exactly. So let's move on to the next slide.
So here is our next section is evaluation and results. As you can see from this slide, we have successfully implemented and uploaded our model to Hugging Face. So our model is considered as open source, and you can successfully download it and use it in your further projects, whether it is connected with learning Kazakh language and expanding the Kazakh data set. So you can simply use this model that is uploaded on Hugging Face. And as you can see here, the average. Okay, next. Here you can see the table. So here's some models. You can see the MT5, MT-Verta, Roberta. This is all the natural language processing models. And here you can see the column called EM and if F1. This is the evaluation matrix. So simply we can say that it is the accuracy percentage of each model. So we can see that as is. So models as they. For example, for MT5, it is no here. For MT-Verta, it is 64%. For Roberta, it is 61%, and etc. And we have taken these models and fine-tuned it on Kazakh Squad. And as you can see, for Kazakh languages, the accuracy rate is 53%, for example, for MT5, and 75 and 7 approximately. Okay, next slide. Here you can see we evaluated our output using the automatic evaluation system called algorithm called Blue. It is bilingual evaluation, and as you can see, the accuracy check is 0.39, so it is 39%. but this accuracy does not coincide with the results. So we can explain it and argument it that Kazakh language is considered as a hard. It has complex grammatic structure and a lot of synonyms. So that is why the real results are low. But it will be much more better if we use the Meteor instead of Blue, because Meteor is works with, for example, synonyms. And we have checked our results manually, and the accuracy percentage was more than 90.
Okay, then
next.
And the next step that we did is develop a user interface for our model. As you remember from the previous slide, we have already well-developed, deployed API. So that is why we use this API in our interface. This interface also works, assess context, assess question, and generates the answer. And moreover, this interface is developed for expanding our dataset in the future, because Squad supports only 1,300 records. That is why we need to expand it in order to develop our model in the future.
So, okay, as you can see here, we have here two text fields, and first of all, it is for context, and second, it is question for this context. Based on this context, and with the help of the interface, we can enrich our data sets in Kazakh language. Okay, next. As conclusion, we developed a Kazakh T5-based question answering model using minimal resources and automatic translation tools to convert the Squad dataset into Kazakh Squad. We compared its performance with other native and large multilingual models for question answering. Results showed that large multilingual models outperformed monolingual models for Kazakh, indicating no need to create native models from scratch. And achievements?
Talking about achievements, we already started to implement our model to other systems. First case that we did was a YEPAM case, where we must develop the Kazakh literacy boost application. So we just implemented this system to our solution, and we got an investment with the amount of 300,000 tenge in order to develop our model in the future. The second one is that we developed a user interface, as we showed in the previous slides, to expand our dataset in the future. So, and last thing that reached is that our model has more than 400 active users per month.
And yes, research are increasing. So further research, we are planning in the future, increasing training data and increasing number of training epochs in order to make it accurate multilingual models, semantic specialization, and interactive learning. Thanks for your attention.
Thank you very much.
If you have please, yes,
questions.
I have one question. You have mentioned some models. Could you tell the differences between them?
Yeah, when we in our
Курицу как готовишь? Курицу как готовишь?
We have just now we have 4 models. So first of all, it is small 10, CAS small 10, CAS small 30, and CAS base 10 and CAS base 30. So the difference between them, small are trained in 1,000 data, and base is trained on 30,000 data.
Thank you very much. So,
and do you have another questions?
We have not.
Okay.
So the next presenter, Shakhtar Sharak Sarijao, Dr. Sudhadgar, hybrid ABC-based machine learning approach for smart irrigation system. Are you here? No. So the next presenter, Asiljan Isbasar, Pakizar Shamoy, image-based dietary assessment, a healthy eating plate estimation system, please. Please, Asiljan, start.
Thank you. Good afternoon, everyone. So my name is Asiljan, and we are presenting. I'm presenting here our topic. This is a image-based dietary assessment, a healthy eating plate estimation system. As we know, year by year, our healthiness level, so eating food consumption is becoming more and more lower by eating some kind of fast food, some kind of stress systems of our health. So food recognition and food recommended systems, they're building and generating some kind of recommendation is becoming higher and higher. So we are introducing you with my supervisor, so the new approach of the system by using the previous researchers of Harvard University. So please, next slide. So as a content of my presentation, here we divided into the 6 parts, as including a reference. I am introducing you the general objectives of the system and telling you the methodology. Then in the end, we are generating some kind of results, and then going to the questions and answer section as a methodology. So as we discussed earlier, the model life have shifted significantly, as we know by ourselves. The reason of I am choosing this topic is I'm interested in my healthy diet of eating, also because of my favorite dish as a kashfarma. I want to getting the experiment and how is the health level of this dish, and we are trying to make some kind of experiments with a plate. So in the plate we have several items of the food, and we are getting the estimation based on the Harvard research. Next. Then, as we see here, so we reference this kind of materials of Harvard that one half of the every plate have to be vegetables and fruits, and the one first part is the whole grains, and the remaining part is healthy proteins. So we can add to that plate, to that bowl, we can say the water is a health oils for balancing all the ingredients, and for not getting some kind of heartaches, some kind of unbalanced feeling after the dish. So our research is based on these materials. Then please. So as a methodology, we propose this kind of structure that consists three kind of parts. This is in general, as a technological part, it's a content-based image retrieval. So we use some semantic segmentation and classification algorithms. Then, after determining segmentation and the classification of every object on the plate, we are calculating with our formula that based on the research, Harvard research, the balancing and the healthiness of the plate. So as we can see here, we have the clustering part of the plate, then we have this extraction part with a database that consists of visual data of the contents, but in our case we choose the color as the features, then we are classifying it, and we are getting the evaluation of the healthiness. This. So we can see here the basic methods of machine learning algorithm. The algorithm itself, we are first of all grouping to the dictionary as vegetables, fruits, grains, and proteins. This is a subset of the main fruits and the grains. Then we are using the region growing algorithm for segmenting the clay. We choose this kind of clay for our experiment. And by the formula, so after determining the segmented parts and determining the classification of every object, so if you have some apple or some kind of proteins as a chicken, meat, we are determining them, and we calculate it by our formula. So we are determining first class type and then the healthiness of the plate. So this is in the left. So in the left part, we can see the healthiness of our food, and in the bottom we can see the balance of this plate by this formulas, which we choose the four main parameters of the healthiness of the plate. Okay. Then as a result, we are introducing some kind of new novel methodology for estimating this kind of healthiness and the balance of the plate. Then for the requirements of the system, we are classifying this kind of structure. So orange or apple. In this case, we have the precision and recall metrics. As we can see, this matrix is very kind of good with a machine learning algorithm like CVM, and we are trying to use some kind of classification algorithms like decision tree, but CVM is showed a good results. Thanks. And we can see here the segmentation parts. So as I said earlier, we use for the training set the co-annotation. So we annotate first of all some kind of data, and then we are segmented in parts using the color-based features. So content is color for our case. And for conclusion, in the previous slide, we set the prototype of the system because our system, based on our system, we can create some kind of application for evaluating the balance and the healthiness of the plate. And this kind of structure and methodology can help for the person and people to evaluate their diet and not going to nutritions and getting the scheduled diet system for shorten the weight or some kind of purposes of the person. So thank you for your attention. I'm done.
Thank you very much. So questions, please. Have any question? Alia?
Yes.
Okay, please. Can you? Okay. Come.
How does your model classify wrapped food, for example?
Classifying wrapped food.
Yes, for example, Varenyky and Lili, Mante, they have different feelings, and so it's how the system reacts.
Yes, reactive present. Okay, thank you for the question. This is a frequently asked question for our research because we have now the experimental settings. If you look for the research paper, we have the experimental settings for not getting the whole generic part of the system as a if you have mantle or some kind of structures that we have inside of bread or some kind of gems, we don't consider it for now, and we just consider some cutted fruits, cutted vegetables, and there's a fried like fried like meats and grains itself, not by the generic parts, so by the consumption or by the mixing the bowl. So our system now are working with separated ones. So separated foods and then classifying them, because it is for our research is the next level of difficulty.
Thank you very much. So, dear participants, now our session will be finished. So I should ask Dr. Sharat Sarirao, Dr. Sudha Gar, are you here? No. Nelly is absent too. So dear participants, I should finish our session, and we wish you all of the best, and thank you very much for your participation.
Thank you. Goodbye.